Everything from your phone to the biggest supercomputers, it's all built on a foundation of these tiny, microscopic switches. They're flipping on and off billions of times a second. Today, we're going to pull back the curtain on that one fundamental component that makes it all possible, the bipolar transistor.
So here's what we're going to cover. First, we'll figure out what a transistor even is. Then, we'll see how they're built, get a handle on its 3 main operating modes, explore the 3 different ways you can wire it up, and finally, we'll put them all side by side to see how they stack up. All right, let's jump right in. What exactly is a bipolar transistor? And more importantly, why is this little thing so unbelievably critical to our modern world? Okay, at its very core, a transistor is all about control. The absolute best way to think about it is like a water faucet. A tiny, easy turn of the handle, that's your base current, can either unleash or completely choke off a much, much larger flow of water. And that's what we call the collector current. Seriously, that simple principle, a tiny input controlling a huge output, that's the magic behind the transistor. And get this, the name itself is a dead giveaway to what it does. Transistor is just a mashup of 2 words, transfer, varistor. It literally means it's a resistor whose value you can change with electricity. And that ability to change its resistance on the fly is what lets it be both a switch and an amplifier. So how in the world do you actually build one of these little electronic faucets? Well, the construction is actually surprisingly simple. It's really just a sandwich made of some special materials. Yeah, it all comes down to a 3-layer sandwich. You take these things called semiconductors, one type called P-type and another called N-type, and you stack them up. You can do it either as PNP or NPN. This creates 3 distinct zones, which gives us our 3 connection points, our 3 terminals, the emitter, the base, and the collector. Now, here's a really cool way to picture this. You know what a diode is, right? It's a simple little 2-layer component, just a P and an N layer stuck together. Well, a transistor is basically like taking 2 of those diodes and sticking them back to back, so they share that middle layer. That's it! That simple fusion creates this incredibly powerful device. Okay, so we know what it's made of. Now let's get into the really cool part. How that simple 3-layer structure gives the transistor this incredible dual personality. Its ability to act as both a dead simple switch and a really sophisticated amplifier. And this right here, this is why the transistor is the absolute bedrock of all electronics. In the digital world, its ability to be either completely on or completely off, well, that creates the 1s and 0s of all computer code. But in the analog world, its ability to operate somewhere in between those 2 states is what lets it amplify weak signals, like the music coming through your headphones. So you can think of the transistor as having 3 main modes. In cutoff mode, it's basically a roadblock. No current gets through. It's an open switch. Then you have saturation mode. Here, the floodgates are wide open and current flows freely. It's a closed switch. But the real magic, that happens in the active region. That's the delicate in-between state where it can precisely boost a signal. That's when it acts as an amplifier. But it gets even more interesting, because it's not just the transistor itself that matters. It's how you connect it in a circuit that totally defines what it does. There are 3 basic ways to wire one up, and believe me, each one gives it a completely different personality. First up, we've got the common base configuration. In this setup, the base terminal is the common connection point for both your input and your output. You should think of this one as the specialist. It's not the one you see everywhere, but for certain jobs, especially with high frequencies, it's absolutely unbeatable. So what's its specialty? Well, it's fantastic at boosting the voltage of a signal. I mean, it gives you a big voltage gain, but it doesn't really touch the current. This makes it perfect for things like the very first amplification stage in a microphone preamp, or in radio circuits where you need to amplify a tiny weak voltage signal coming from an antenna. Next up, we have the undisputed champion, the most popular and versatile setup of them all, the common emitter configuration. This is the true workhorse. You are going to find this in the vast majority of transistor amplifier circuits out there. This guy is the all-rounder. It boosts both the voltage and the current, which means it gives you the biggest possible increase in overall power of any setup. It's just incredibly useful. There is one little quirk, though. The output signal it produces is a mirror image of the input. It's completely flipped upside down or inverted. And last but not least, we have the common collector configuration. People often call this one the emitter follower. Now, this one isn't about getting massive amplification. Instead, it plays a really crucial support role in a circuit. Its superpower is being a matchmaker. See, sometimes you have a signal source that's a bit weak. It doesn't like to drive a heavy load. This configuration can connect that weak source to something that needs a lot of current, and it does it perfectly, without any problems. It's like a universal adapter, making sure the signal gets through nice and clean. It gives you a big boost in current, but it leaves the voltage pretty much the same. Okay, so we've met the specialist, the powerhouse, and the matchmaker. Now let's put them all side by side so we can really see what makes each one unique, their strengths and their weaknesses. This table just lays it all out beautifully. You can see right away there is no single best setup. It's all about trade-offs and picking the right tool for the right job. You need a big voltage boost? Go with common base. Need the most overall power gain, the most bang for your buck? Common emitter is your workhorse. Or do you just need to connect two mismatched parts of a circuit? Well, common collector is the perfect bridge. And that's really the key takeaway here: incredible versatility. Just by changing which of its three terminals is connected to the common ground, you can make this one single component behave in three completely different ways. You can tailor it to fit almost any electronic task you can dream up. So that leaves us with one last thought. While all three of these configurations are absolutely essential tools in any engineer's toolkit, one of them, that all-around powerhouse, truly did become the foundation for the huge majority of amplifier circuits that we all rely on every single day.